Okay, now members, let us see the angle of friction. This is an angle between the resultant T of the frictional force F and the normal reaction. So this one, T is called the total reaction. So the resultant, if you have this and this and this is called, if you have the normal reaction R and then the frictional force F, then the resultant, or what we call the total reaction, between this R and then F, the angle between them is what we call the angle of friction. Now, let us consider the resultant R and F with the, let's consider the reaction R and the friction of F, and then also the resultant of these two, which is T. Now, note that because this one is the angle, so this side is going to be the opposite. And this one is going to be the adjacent. So always now, so this force will be here. So tan theta is equal to the opposite, which is F, over the adjacent, which is it's going to be R. Normal reaction R is constant, but frictional force may vary because the normal reaction of the body, between bodies of the between two bodies in contact, it's constant, for it doesn't change. But the frictional force is going to change between the body, between the time when the body is at rest and then when the body is about to move. So it's going to change. So for it, it's varying. So if F increases from 0 to its maximum, remember the maximum value of the frictional force is mu R. Theta also, now this one will also increase from 0 to its maximum, theta max equaling to R, equaling to lambda, and this lambda is called the angle of friction. So now, where this is at maximum, we have this, and then this will also be at maximum. Maximum will be equal to the lambda, and then also the resultant will be T maximum, or the total reaction will also be at its maximum. So from there, tan of Q maximum is going to be theta, this is theta maximum. Theta max is going to be equaling to this C over R. But at F maximum, we say this is equal to this, which we in the sum we have that. And so our R is going to vanish, and so we shall be having tan lambda equaling to mu. Or if you get lambda, we have the tan inverse of mu. The magnitude of the maximum reaction Tx given by, you see that now if we have this, remember this is going to be like this. So this force here, if we have to resolve it like that, resolving it in this direction, also this, because the maximum is there. So if you want to get the magnitude we get now, we shall get the square root. Remember, when the square is equal to the square of this plus the square of this we have there. So it's that R squared is common, we factorize it. We have 1 plus mu squared. Remember our mu is this. When we square it, we have now tan squared lambda. But no 1 plus tan squared is the same one sec squared lambda. And then when you get the square root of this together and the square root of that together, because this is the product, you can get the square root of the separate terms. So now the maximum, the magnitude of the maximum reaction is going to be that. Important points when solving problems involving frictional force F. Draw a clear diagram and show the frictional force F. Don't use mu R. If F has reached its maximum value, I of F is this, then F equaling to this may be used in the solution. The limiting equilibrium means the body is at rest but at the point of moving. So whenever I hear limiting equilibrium, the body is still at rest but it's about to move, meaning friction has reached its maximum mu R. If the body is in equilibrium, then the equations of equilibrium and F, because the body is in equilibrium, are used. If lambda is given and mu and not mu, then it's often easier to solve the problem by considering the resultant reaction rather than F and R. The resultant reaction, this one. The resultant reaction, this one. Rather than consider this and this, or rather than considering this and this, we better consider this if they give us the angle of friction. This is a common case in the three case problems as we are going to see. So, after now knowing how we get the angle of friction, then this new the coefficient of friction, which is the roughness between the surfaces. Now we are going to see examples of how we apply what we've seen. And so please don't forget to subscribe to the channel. I wish you well.